All right. Okay. Let's see. We got that going. We can get rid of that. We can show this. And now we got to get your file. Okay. So, hey everybody. Looks like we got our stream going. And I'm just getting a file. Gotta check something real quick. Checking on some stuff. And let's see what you want to do. So, all right, guys. Cool. Okay. So I'm working with another guy, Tom. Shout out to Tom Shoes World, and Tom's in a position where he's learning to do kind of the deep end of the pool type stuff. So he's jumped into 5-axis. Let's see. Let's make sure we got mic auxiliary. Somebody says there's some crazy music playing. I'm not sure what audio. Oh. Okay, good. If you guys hear some background noise, there's a bunch of cars driving by. I live on a main highway. It's pretty loud, so I apologize for that. Hopefully I'll be moving here soon. Just had a wild week. Truck hit my house. Actually smashed my Subaru into my house. My Subaru's maybe 4 feet wide now instead of 7 feet wide. It's pretty nuts. So, okay, cool. So we've got a 5-axis part we're going to take a look at. So let's go open this up. Oh, let's see. So this is earlier version. What are you using, Tom? Are you in 2020, 2019? Because I can do it in any version, really. For 5-axis trimming, 5-axis in general is being improved in Mastercam in a lot of ways. And a lot of that has to do with the technology that's being used under the hood. And what I mean by that is the particular Toolpath technology. A lot of it is being developed by a company called ModuleWorks. And that's one of Mastercam's partners. And basically they make Toolpath and simulation modules and other software components. And then they license them to companies like CNC Software, the guys that make Mastercam. But there's a whole bunch of other CAM softwares that also have access to this underlying technology, which is good for anybody that's learning 5-axis. And it's good because, in the future, if I love Mastercam. That's part of the reason why we're, doing this demonstration here in Mastercam. I've been using it for 20 plus years. It's, made me a lot of money over the years and kept food on my table. So I'm grateful to the guys that developed the software. But that said, market forces dictate who succeeds. And, as long as they keep servicing the customer and creating good software, I foresee them having a great, successful future. But the point is, a lot of software companies are using the ModuleWorks technology underneath the hood. And so the more you understand how to drive ModuleWorks toolpaths and use their options, the more software packages you have access to, because then you just have to use the user interface, the inputs and outputs for what drives the software, and that makes you a more valuable programmer. So we're going to talk about 5-axis curve programming, and this happens a lot where you're given this piece. Let me go ahead and turn off translucency. And the other thing you'll notice kind of by default is the coloring on the model. First thing I'll do is save this. And what I like to do is go up under this Appearance tab. So we're on the View ribbon tab here in Mastercam. I'm going to click on Shading Options, which is this little button that's down in the corner. And I like default light mode is 1, and you'll notice there's a bunch of shadow here. I like light mode 3. It kind of brightens up the scene just a little bit. The other thing you're going to see with shading, it affects how solid faces look when you're in unshaded mode. And so here's what I mean. Whenever you're looking at modeling, all of this complex 3D geometry is created using simple 2D geometry. So we always start out with 2D geometry at the heart of creating a 3D design. And there are different schools of thought and different methods of creating. The one that has kind of won out and become the de facto standard is solid modeling, where you're kind of starting with what you can think of as a solid block of clay or some other material, a physical object, a rectangle, a cylinder, a sphere, and then you're carving away pieces of that object and then applying details. So typically the last thing that we would be putting on a model like this is features like chamfers and fillets. So the final smooth curves that smooth everything out. And so what we're going to look at today is how do we, work with a 5-axis part like this for doing trimming. I mean, that's what we're talking about specifically. So we're going to take this molded plastic part, we're going to stick it on a vacuum fixture that's probably already been made to hold that shape, and then we're going to run cutters around the outside to trim out the part and leave what's behind. And the other thing that Tom's dealing with, he's got an as and an opposite part. So how do we deal with mirroring? And there's multiple options to handle that in Mastercam depending on personal preference, but also just depending on what specific toolpaths you're using to drive the operation, because the types of toolpaths you're using will have an effect on how does the transform operation work. So we can do a bunch of stuff. One of the things we can do is transform multiple copies of a part and just have a different work offset. So we're calling the same set of code, same XYZ motions, but we're calling G54, G55, G56, different work offsets. For older machines, they don't have work offsets. So a lot of the older machines work off of what we would call a local coordinate system. So local coordinates is G92, which is where you're physically jogging the machine to a position that's near the part that's a known position. So typically you've got like a dowel pin or something in the fixture that's going to be your start location. You're going to jog your tool till it's aligned with that start location, and then you'll give it a G92 command. You say my cutter is 10 inches negative in X, it's 0 inches in Y, and it's 3 inches above Z0, because you've measured it and you've located it in that specific location before you start cutting. So there are multiple ways to run the router, but what we're looking at is how do we drive the toolpath. Finishing off the shading, one of the things I like to do here is I like to change this radial display curve angle. What this is doing, if I change it down to something like 5, when I unshade this model, you'll see this here in a sec. So when I unshade this model, because I've set my radial display curve angle at 5 degrees, what you're noticing now is that there's a bunch of contour lines that are shown on the curved surfaces of the part. So notice it's only on the curved faces, although there are some faces like over here where apparently that curvature is not getting applied, even though I think it should be. So this guy right here, this guy right here, it could be because they're curved in multiple directions and these other guys are not. Hard to tell, because you can see down here, these are probably curved in multiple directions, and there you've got multiple display lines. And so what we're talking about is the amount of display lines on the surface. So I've got the model here in unshaded mode, and I can toggle between those options up here using the appearance commands on the ribbon bar. So right now we're in what they call wireframe. So rather than it being a reflective surface as if it was a solid physical object, it's shown where just the edges are kind of highlighted. If you notice, if I go into outline shaded, that shows it back as a full solid object. One of the things I'll also do, I'm going to left click on it to select it, and then right click. And I right click to access this right click menu, which gives me quick access to a lot of different commands. So I've got some zoom commands: zoom window, unzoom 80%, dynamic rotation, screen fit. I can choose different views: top, front, right, ISO. Some of the auxiliary views, or views that aren't as commonly used, are accessible under that G view flyout menu. And we've also got access to kind of our quick attributes up here. So we can change the point style, line width. We can change the color for geometry creation. So we've got different creation colors for wireframe, solid geometry, and surface geometry. So for example, I've got this solid selected. I'm going to go up to solid geometry here, and let's choose a color that's less dark. And that's just one of those personal preference things. I like to have my background typically be a darker color, and the part itself be a lighter color, just so I can distinguish the features visually in an easier way. So one of the first things I can see just visually looking at this model, based on the way it came in, we've got an error in the model. So if I do a dynamic rotation, you'll notice what we've got here is a case where it looks like this solid face right here, kind of on both sides, somehow got inverted, or it got, something messed up happened to it as we were importing the solid. And the reason that can be a big deal is when it comes to working with this as a solid model, if we have a hole in the model like this, it often makes the entire solid into what we call an open sheet body. So rather than it being a solid block of clay, where we can know things like the volume of it as an object, as a piece of mass, now it's this open shell. So that can be an issue. And if that needed to get fixed, what I would end up doing is converting this into surfaces, creating some surfaces here to patch up that hole, and then attempting to join this back together as a solid from surfaces. So, we can certainly look at doing that. However, the other important thing to note about that is that we don't necessarily have to repair that hole in order to toolpath this object. So let's look at how this thing is going to fit. So I am just guessing that when we set this up, that this face here should kind of be flat in terms of 3D space, located somewhere on the router. So when these parts come in, often they're off in 3D space at some random location. So the first thing we have to do is move it back to the origin and align the part to get it normal to the machine coordinate system. In Mastercam, they call it the WCS, which is the World Coordinate System. I prefer MCS, Machine Coordinate System, because that's really what we're doing, is we're taking the XYZ orientation of our machine, usually using the right hand rule. Your thumb is X positive, your first finger is Y positive, and you hold that flat to the floor, and then your middle finger points straight up to indicate Z positive. And then we would have standard axis of rotations around XYZ is ABC. So we'd have A rotating about X, B rotating about Y, and C rotating about the Z axis. So to align this model, first thing that I'm going to do, I'm going to go to my transform ribbon bar, and I'm going to choose this dynamic option. So it says manipulate geometry, orientation, and location with an interactive gnomon, Gnomon. They pronounce it gnomon, but it's basically this little Cartesian coordinate system down there. You can click, hold, and drag and drop this on the part to start the command as well. There are always multiple ways to get to the same thing in the software, but in this case I'll just choose dynamic. So select the entities to move or copy. What I'm going to do is go down and click on the solid and then press End Selection. And now you'll notice it says to pick the gnomon position. So this gnomon that we're using, this little XYZ coordinate system, has a bunch of different functionality that's built into the icon itself. What I'm going to do is I'm just going to move this icon off the part, and I'm going to click randomly. Now, as soon as I do that, there's a setting in the software that tells it to automatically go into geometry translation mode. But I don't want that to happen yet. What I want to do is I want to manipulate the gnomon to make sure it's properly aligned to my part. So you'll notice there's this little grayed out icon that shows geometry. That's what these little solid pieces on the icon represent. And actually, if you look at my cursor, the back end of the cursor has that geometry as well. That's telling you you're in geometry translation mode. I'm going to click this button because I want to stay in gnomon manipulation mode, not geometry manipulation mode. I want to be able to manipulate this and align it to my part before I start moving my part. So if you look at this gnomon, you have multiple controls that are on the piece itself. I'm going to hold down Shift on the keyboard, and I'm going to center click with my mouse to flip between rotate and pan. So by default, we're in rotate mode. If I hold down Shift, I can pan. So when you look at this little icon, you'll notice that each piece of the handle is a different piece of rotation depending on which axis we're rotating about. The shafts of the Cartesian gnomon itself allow us to translate along a linear axis, and the little cone head is a special one because the little cone head says stay normal to a particular surface or face. So each part of this thing has a different function, and one of the functions that's special is the XY plane. So you'll notice if I put this in the center of my Z and Y axis over here, it doesn't highlight. And if I put it in between the window here for X and Z, it doesn't highlight. But if I put it in the little quarter piece of a circle down here, that says I want to align the XY plane of my gnomon to something. So what I'm going to do is click on that little yellow face, and now it says pick entity to align gnomon to. So I'll zoom in on my part, and as soon as I hover over that flat face, it actually perfectly aligns my XY plane to that flat face. So I'll click on it. So now I've just realigned the gnomon to be perfectly planar with this top face. Now I need to choose where the origin point is. And that's really going to be based on aligning it to some type of fixture. So let's say, for example, we've got, some point on our fixture that's on the midpoint of this edge right here. And by the way, I'm just rotating the model by center clicking on my scroll wheel and holding down that scroll wheel and then rotating or just moving the mouse. And that's what's rotating my geometry. So I'm going to click on the little origin ball because we're still in gnomon manipulation mode. And I'll find the midpoint along this fillet radius. Because I'm guessing, if we had a fixture, it would have the same, contours, and so we would be able to match that up because we typically already have our fixture aligned to the world axes. So I am now done manipulating my gnomon. I've got it aligned perfectly to the part, and I've got the origin set on the midpoint of that front face. So now what I can do is go back into geometry manipulation mode. So I'll click that, which puts me in geometry mode. So now I've aligned this gnomon to my part. And now over here on the function panel, you'll notice we've got these options, origin and axes. So what I want to do is I want to align my part to the world axes. So I'll come over here and click on world, and that flips the entire part around so that it's aligned with the world XYZ. And I also want to bring it to the world origin. So I'll click on world, and that's going to move my part. And then I click OK. And if I now turn on my origin lines with the F9 key, so F9 on the keyboard will turn on my XYZ origins. And then I right click and I look at this in the top view, or right click and look in front, or right click and look in the right view. You can see that the part is now aligned to my world coordinate system. So now we've got to figure out where's that origin going to be on the machine. If we're able to set a work offset on the machine and our post processor is set up to use something like dynamic work offset or tilted work plane or tool center point control for 5-axis, then it doesn't matter where we set that origin, as long as it's a place we can dial in on the machine. So if we can use a probe, or if we can use a pin and an indicator and sweep in the spindle location, the origin's really just going to be where's the origin on our part and what kind of fixturing are we using. So I'm going to say we're going to imagine that the fixture is some point, or the origin is going to be some point on our fixture, and we're just going to physically offset our part to compensate for that. So let's do something like this. I'm going to take the part, we'll translate it up in the air, say 20 inches. That's a little high. Let's go 15. We'll go 15. And in Y, we'll go 30. And in X, we'll go 20. That's a little far. Let's go 10. So now if we look in the top view, you know, we've got this part. I'm going to move it over a few more inches. So we're going to go over, let's go 10 inches in X, but let's go minus 10 in Y. So I'm just going kind of based off some pictures Tom gave me of how he's got this part set up, because part of what this is, there's a left and a right part that are going to be cut out of the same molded part. So we're going to say, okay, there's that origin point that's on our fixture. We know the distances that these are offset. You know, we could always do, you know, a short thing on vacuum fixture design at some point, but in this case, we're looking at doing the 5-axis cuts. So one of the things that happens when we bring in a solid model and we start moving it around like this, we need to take this and make a mirror image of it. But we've also taken the model and we've done some transformations to it. So we've reoriented it in 3D space. We've moved it to our origin, but then we've moved it up and over and we've offset it. And every time we do that, that data gets kind of stored in the background as part of the model, and it leads to bloating of our geometry database. So one of the things that I like to do after I've got my model in place, I'm going to go to my model prep tab and I'll click on remove history. So it only has one solid, so I'll select that guy and hit end selection. And that basically cleaned up the model and made it kind of what we would think of as a dumb solid that doesn't retain any of its former transformations. So I'm going to go ahead and save that. And let's make a mirror image. So I'm going to select it and choose mirror. We're going to mirror about the y-axis. So you can see I'm copying it straight across there. And I'll select OK. And when it comes to making a mirrored toolpath, it really depends on how our original toolpath was set up to begin with. So this particular case right now, we've taken our simplified solid and we've copied it. We've made a mirror image of it. And anytime you do a transform operation in Mastercam, so that's under the transform tab, and we've got translate, rotate, project, mirror, move to origin. We've got some offset commands. Anytime you perform one of those functions, what you get in Mastercam is called a group and result. If there's a copy. So if there's a copy operation, the group is shown in red and the result is shown in purple. That's the two group and result colors, which is why I like to recommend people not draw in red or purple. Just, you know, out of habit, these are the group and result colors, so they mean something, they indicate something, which is why I like to draw in other colors besides these. So when you perform a transform op, if you're moving something, you'll only ever get a result. You're only ever going to get a purple color because the group and the result are one and the same, and so that is always colored purple. So over on the right hand side of the screen, you'll notice we've got these quick mask buttons. Two of the buttons that we've got are select all group entities and select all result entities. So depending on what you're doing, if you're making multiple copies of something, for example, if I took both of these guys and said translate, copy them along the y-axis, let's go 20 inches, and I said make 4 copies, you'll notice here it could be advantageous to be able to select all of the group or all of the result if we were, manipulating a lot of geometry. So in this case, I'm going to X out of there. But it's important to note there's the select all results and select all group buttons. Some of these buttons are split, and they're split with this little diagonal line, and the upper left half of the button allows you to select all of something. The lower left half puts you in an only selection mode. So where would that come up? Well, let's see what happens if we create some geometry here. So I'm going to save this. I'm going to go into my Wireframe tab, and we'll go to Curve All Edges. And I'm going to right click, make sure I'm in 3D mode, and then I'll go ahead and triple click each of the solids to select the entire solid. So in this case, I've allowed it to create wireframe geometry on every edge on all piece of my solids. But what I'll do now, I'm going to leave it same color, same everything, but I'm going to perform this again. So I'm going to do Curve All Edges. I'm going to triple click on both of these solids. And then I'm going to go over here and select all wireframe entities. So this top button here will let me grab everything. And I'm going to right click, and then I'm going to click on this little button here and say copy. And we're going to copy this to level 10. So why am I doing this? Well, I'm doing this so that we have a lot of extra geometry, just so that we can look at some ability to filter that stuff. So if I go to my Home tab and click on Statistics, that'll show me what kind of geometry I've currently got visible on my screen. So right now I've got 4,302 lines, 4,430 arcs, 3,900 splines, 2 solids, 1 tool. And this can happen sometimes where you go to import a model and it just comes in with all this extra overlapping geometry. So what do? Well, here's what I typically do. I will typically just go and I will delete all the wireframe geometry or move it to a different level. So if I'm worried about not being able to get back or something like that, I'll move it to a different level so that I can use some options to sort it later. And in this case, I'm just going to go ahead and select it all and then just press delete on the keyboard. And then I'm going to save the file. What I like to do for creating wireframe is to create the wireframe geometry specifically where I need it. So where do I need it? Well, I need it basically on the edges of the part. So the edges that I'm going to cut are already defined for me by the edges of this model. So let's do this first. We're going to go in the top view. I'm going to click on the left side of the part. I'm going to right click and I'll move this to a different level. And we'll call this left part solid. And over here I'll choose force visibility off. So I'm going to move it to a new level and turn off the visibility. If I look at my levels panel right here, you'll notice that we've got one entity here, just says fillet 43, but that's really our right part solid. So right part solid. And I'm going to create a new level. going to go down here and type in 10, create level 10, and we'll call this right part wireframe geo. So the geometry for the right side part. And I'm going to right click and go to my color and choose a different color to create in. In this case, I'll choose kind of a brighter blue. And now what I want to do is think about what kind of path do I want my cutter to follow. We have two intersecting planes when it comes to these edge cuts here. So I want you to look at the difference between something. If I go to my wireframe and I select curve on one edge, you'll notice that where I have a single face, I'm getting a solid edge. So there's an edge there, an edge there. And this happens because it's recognizing the shorter edge of the solid. I can do this directly off the solid model, and most times I will, but I want you to see the difference between creating it off of a single solid edge like this and what happens if we end up with a surface. So let's just do this. I'll create the edges that I want first, and then we'll create a surface off of there and look at what happens if we have a different shape. So on the back edge of this part, I'm just going to click on all these edges where I want to create my wireframe. And this is basically the bottom edge of the part. And part of why I'm doing it this way is so that I get a single piece of geometry for the edge that I want my cutter to follow. Now, by the way, I can use the solid. I can chain right off of the solid if I want to. But part of why I like to create the wireframe is that it allows me to manipulate the geometry. So what do I mean by that? Well, first thing I'm going to do is go in here and choose my line width. And I'll go with kind of a medium weight line. And then I'll use my wireframe selection here, and I'll choose select all wireframe entities. So that chooses my existing wireframe. Then I'll right click and I'll choose that medium line width. So I've changed the line width of the geometry I've already created, and now when I create new curves, they'll show up in that thicker line weight as well. And part of the reason I'm doing that is because it makes it easier to distinguish where my chain really is in 3D space, because I can manipulate the color and thickness and differentiate it between the chain that I'm creating for a toolpath and my actual real solid. So I'm just going along here. Now, keep in mind, I could have said, give me all the edges of the solid face, but I might not get individual edge curves the way that I do if I pick them manually. So that's part of why I'm doing this. So we'll go along the edges. There's one more over here. Yeah, we got some interesting geometry right here for sure. This little sharp cut. So we'll have to look at how do we deal with that. And I'm manipulating the part with my mouse and by holding the shift key. So when I want to pan, I hold down the shift key and I center click. And when I want it to rotate, I let go of the shift key. And then I just click and hold with my mouse. You can see here's an interesting case here where we've got this cutout that intersects this solid face and this solid face. So we end up with these two pieces of geometry. It's not going to hurt anything in terms of toolpathing to have this separate little piece. But we have to be aware of it, because if we miss it, then we have a broken chain, which can be a problem when it comes to toolpathing. And now that we've went around and kind of traced the bottom outline of that part, if I turn off the level with the solid, we should be able to kind of visually inspect the chain. And one of the first things I can see, so we're missing a piece. So I'll turn it back on, I'll go back into create curve one edge, and then turn my solid off again. Now, how do we know if we've got a complete chain with no branch points? I'm going to go ahead and delete that little extra piece of line that we had sticking out there. One of the tools we have for geometry selection is the shift key. So if I hold down the shift key and I click on one of these pieces of geometry, Mastercam is going to go into geometry selection chaining mode. So it starts a chain and it starts going around, it goes all the way around, and it keeps on finding entities that are tangent, but it stopped right here. So there's a problem. It stopped here, and we have to kind of discover what that problem is. It could be two pieces of geometry that are overlapping. It could be any number of things. I'm going to go ahead and hit escape, and then I'll go ahead and save the part file, because we've been working on it for a while, so it's important to remember to save regularly. Now the other thing I'm going to do is under the Home tab, there's an option here for arc center points and endpoints, and these are display options that I'm going to toggle on. And when I do that, you'll notice that I've now got this little orange center point for all the arc entities. And here's another one over here. There's an arc. You see its center point there. There's another arc. So I want to be able to determine what's a line, what's an arc, what's a spline, what do I got? Now over here, it's hard to determine if it's just something that's not trimmed or if there's something overlapping. So one of the tools we've got here, if we're trying to determine if we've got overlaps, there's this option up here called Verify Selection. So if I turn on Verify Selection and I move my cursor over the top of this line and I left click once, you'll notice that we get this little verify option that comes up. And now if I press next, it's going to toggle through my choices. And the fact that it even brought up the verify selection window at all tells me there's multiple pieces of geometry there. So I'll go ahead and I'll click OK, and then I'll press delete on my keyboard, and you'll notice that there's still something there. That's what told me it was overlapping. I'm going to press undo because I want to show this to you. So I'm still in verify selection mode. If I move my cursor over this guy and I click on it, you'll notice that it just highlights in yellow. And it just highlights in yellow because there's nothing else that it could possibly select in the area that I clicked. I'm going to move my cursor down here and click on this guy. And you'll notice it just simply highlights because there's nothing else that it could have selected. The same is probably true here. It's also true here, here, oh, and now I find that I may be getting multiple pieces. So I can click, and you'll notice here, it's just seeing that there are multiple entities in that area. It's finding this guy here, it's finding this little guy here, it's finding this little guy here, it's finding this circle here, so it's highlighting them in white. So I keep going through the options. That's the one I really wanted, so I click OK. Now I'm going to zoom in. I'm going to click here, I'm going to click here, and as I click on them, you'll notice that it just selects them. Now we go to our trouble spot. So I click here, and again, I immediately get the verify window. Now I'm going to hit escape because you'll notice that I've got other pieces of geometry selected already, and I don't want to do anything with that. So I'm going to hit escape. I'm going to click here. It says verify select. Okay. I'll press delete. We've still got another one there. If I click on it now, you'll notice it just highlights. So that's what tells me the geometry's clean. So I'll click again to unselect it, and then I'll click verify selection to turn that mode off, because it can be annoying depending on what geometry you have visible or not visible. So now I'm going to go ahead and save this. There's one more tool I can use to tell me if this chain is made up of single entities or if there is overlapping geometry. So that tool is a toolpath. So if I go into toolpaths and I choose contour, the contour wireframe chaining should default to full chain selection. Depending on your settings, it could be defaulting to the last mode you used. So you want to make sure you're in full chain selection mode. Now the way full chaining works, when you click near the end point of an entity, for example, this line down here, if I click near that endpoint, what I would expect to happen is that it's going to start near the closest endpoint, and the chain is going to move away from that endpoint. And what I want to see when I'm selecting a full chain is one and only one green arrow. So when I click here, you'll notice it gives me one green arrow and it highlights the whole entire chain in yellow. And it's near the point where I clicked. So I'm going to do unselect, and I'm going to choose the same chain in a different spot to test my theory, is this a complete chain? So I click up here, and again, I get the entire chain highlighted in yellow, and I get one green arrow. So this is a good set of wireframe geometry, but what does a bad set look like? So I'm going to escape out of there. And again, I'm not trying to create a toolpath. I'm not trying to create a contour. I'm just using the contour chaining to try and test my chain and see if it's good or not. So sometimes this can happen. I've got an entity down here. I'm going to select it, and we'll go to the Home tab, and I'll choose Analyze Entity. And it tells me it's a line. Everything looks good there. I'm going to go into wireframe mode, and I'm going to choose line by endpoints. And I'm going to create a line that lies over the top of this other one. So we've got a line here, we've got a line here. They share a common endpoint. Okay, so this is what's called an overlap. I'm also going to go down here, and we're going to go to our modify length, and we're going to choose shorten. I'll do shorten by 4/10. And then I'm going to choose lengthen by 1 thou. So this chain has got some problems. It's got some overlapping geometry, and it's got a gap, and it's got a part that's not trimmed now. So if I had created these chains of geometry and I thought to myself, okay, this looks good. I've got my solid, I've got my chains that I want to use to cut. I just want to check them, see if they're good. So I'll go to Toolpaths, Contour, and I'll choose right there to start my chain. So do you see what happened? I clicked there to start my chain, but instead of getting one green arrow, which is both the start and the end point of a complete chain, it started and stopped, in this case started over here and stopped over here, wherever it found a problem in the chain. So I know I've got a problem over here, and I know I've got a problem over here. So I'm going to go ahead and X out of here. Do I want to keep the operation? No. And then I'm going to zoom down here and see what I got going on. Oop, lost that there. So down here, got a problem where some geometry is not meeting. Depending on what your geometry is, based on the solid that you get, that's going to kind of dictate how you want to go ahead and fix this. In this case, because it's a line, I could simply change the endpoint to connect here. I can also use trim as long as I'm in the correct plane. But one of the problems that we've got, if I turn on the solid and I look at this from the right side, we'll be able to see it from the front. So if I look at from the front, this slice that comes down along the part here is at an angle. And what that means is that it intersects this wall in a way that it makes this this part of the chain non-circular. So these guys here should be splines. So if I go over and I use select all spline entities function, you'll notice that any of my pieces of wireframe that needed to be a spline because of the surface curvature and the way that the solid itself was sliced, those got created as spline entities. Now, a lot of the times you can import geometry and create wireframe geometry, and it'll create splines where there should be a line or there should be an arc. And so if that happens, for example, if we had a linear spline or we had a circular spline and we wanted to convert them into a line or an arc, we can go to our wireframe tab and we can use the command simplify spline. So the simplify spline will convert circular shaped splines to circles and linear shaped splines to lines. And it does so based on a tolerance. So one of the things we can try is just take the splines that we've got, for example, depending on how this cut lies in 3D space, this spline here may be able to be turned into an arc. I'm not sure, but we can always try it. So what we'll do is go and take all splines, and then we'll go to our wireframe tab and go and choose simplify spline. And now we give it a tolerance, 2/10,000ths of an inch is probably pretty good. And I'll tell it anything that you're actually going to convert, go ahead and delete. So I'll say okay, and you'll notice these guys here and a couple of these other ones here, the purple, got converted from splines into arc entities. So I still want to check and see what the quality of my chain looks like. So I know I need to fix these down here. Now, because this is an arc, and we know it's an arc because we can see the arc center point, an arc is always a planar entity. It's always flat to subplane. This plane happens to be rotated in 3D space, but that's okay. This arc is still planar to some plane in 3D space. And what that means is that if I use this arc to create a plane, I can then perform 2D trimming on that plane. So as an example, I'll go in my planes tab here, and I'll go to my create a new plane command, and I'll choose create from geometry, and I'll choose that arc, and I'll choose 2D, 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 2 and it basically gives us a bunch of different options of how we want our coordinate system aligned to that arc. This is the one that makes most sense to me. It keeps Z pointing up. So I'll say OK, and I'll just call this trim plane, because that's what I'm going to use it for. And I'll select OK. And then in my planes panel over here, I'm going to set that to be equal. So setting it to be equal sets my WCS, construction, and tool plane. And what that means by setting the WCS, these views, top, front, right, are now relative to the plane I created. So when I choose top, if I turn on the view of my solid, you'll see that our plane, that our solid itself is actually rotated in 3D space. And so my top plane is actually aligned to that edge. If I look at this in the front plane of my WCS, you'll see I've aligned my view to be parallel with that plane. So we'll go back to top, and I'll turn off my solid, and now I can perform my trimming. So I'll go to trim two entities, choose trim, two entities. I'll choose that line and that arc. I know I had another problem over here, so I'll choose that line and that arc. I've now trimmed those together. But trimming won't necessarily take care of the other problem that I created down here. What I need is to be kind of planar to that section there. So I'll go back to my planes, choose top, look at this in the top view. Now, as I go and create all of these arcs using create curve on one edge, Mastercam can sometimes end up creating multiple parallel planes in the background. And so when we create an arc normally, we want arcs that are planar to the top view to be associated with the top plane. Arcs that are created in the front to be associated to the front plane, and so on. We want to use kind of the least amount of data possible. So after we go through and create all these arcs, there's a function up here on the ribbon for dealing with arcs called combine views. So combine views combines all parallel views into a single view and moves arcs from the parallel views to the single view. So again, this is about managing data and taking up the least amount of resources. And the other thing that you'll see happen is chaining direction. If you want your chaining direction to be consistent when you're picking arcs, use the combine views function. So I'll do combine views. It tells me 16 arcs were moved to a new view. I'll say OK. Then I'll go to my home tab here, and I'll choose the clear colors command to clear out those purple pieces of wireframe. I've still got a problem down here. I've got some entities that are lying on top of other entities. So let's do this. Let's create some more of that, just to show you. I'm going to break this arc in two pieces at the midpoint. Then I'll go into modify length, and I'll say lengthen by 1 thou. So I've got all these problems with overlapping geometry that aren't necessarily fixed easily by trimming. So there's one more option to deal with some of these problem wireframe geometry situations, and that's running a C-hook. So if we go to the Home tab, you'll notice we've got this command for run add-in, which is launching a C-hook. So I'll click on Run Add-in. And these are a series of functions that have been created that run inside Mastercam that kind of extend Mastercam's functionality. They're add-ins to the Mastercam program. So in this case, we're going to use the find overlap command. So there's find overlap, and I'll choose open, and it says select entities to check for overlap. Let's go ahead and grab everything, and I'll hit, by the way, it won't select the splines. So if there's a spline that's on there, this only works on line and arc geometry, so keep that in mind. And I'll do end selection. And so now it goes through the overlaps. So here it brings up the find overlap C-hook dialog, and you'll notice we get first, last, previous, next, cleanup. Down in the lower left-hand corner, I want to point your attention to this. In the lower left-hand corner of Mastercam is the Mastercam function prompt. So the selection prompt is a little dialog that floats on the screen that tells you to select geometry and press enter or whatever you're going to do, depending on the command you're in. The function prompt actually displays information about what Mastercam is doing as it runs commands. So in this case, it says overlapping entity, 1 of 4 line. So it's telling you the problem. By the way, I can, move my cursor, move my geometry around while I'm in the function, right? So if I hit next, it shows me the next overlapping entity. Overlapping entity 2 of 4 is a line. When I hit next, now it's jumping over here. So it sees a problem here, and I hit next again, another line. So it's finding these line problems. So I'm going to go ahead and hit cleanup, and it tells me 2 overlapping entities deleted. Repaint graphics, check for gaps. So what did it delete? It always deletes the shortest of the overlapping entities. So that's how it's set up to work. So I'll say okay, and in this case it left this guy over here, and it left this guy over here. These two right here aren't fully overlapping, and part of that is because I think it's a spline anyway. So I'm going to go ahead and delete those. I'll turn on my level with the solid, and I'll do create a wireframe curve one edge. Yeah, so the problem with this is it's a spline entity anyway. So for it to be an overlap, for it to find it, it would have to be an arc. So I could create, another arc over here or partial arc over here, but I think you get the idea about you running find overlap when you're having a problem with the chain as one of the tools to help you clean up your geometry. So the other thing that we would probably do here, I'm going to select just the bottom part of this chain. So I'll move my cursor towards this endpoint. I'll hold down Shift and click, and it's going to select the whole chain. But I've got the Shift button held down. I'm going to continue to hold down Shift, and I'm going to click near the end point here, and I've kept Shift held down on the keyboard that entire time, and I just let go. So I wanted to select all of that wireframe from here to here, and I'll go ahead and change the color of that. Looking over here, I think here to here is probably a good transition. So I'm going to hold down Shift and click from here to here, and we'll change that to an orange color. Now, part of the reason I'm changing that color is because I want to be able to cut this using several different paths. Now, we could try to cut this using one entire cut. And that, is certainly doable. It depends on, where you need to be able to rough, where you need to be able to make multi-passes. And so in some cases, you may want to do this in several separate cuts with different approach and retract values. So it really just depends on how you want to drive the path. So in this case, I'm going to cut this yeah, we can just try using, we can try doing it with one single path. But if we're going to do a single path, we need some control lines to be able to control how the tool is oriented. So typically I will do that on a separate level. So I'm going to go to, actually, instead of create curve one edge, I'll do line endpoint, because I know I want lines in the end. And one of the tricks I can do is to just turn off the other wireframe geometry. And as I create these lines, let me back up. I'm going to do undo and then undo. So with create line endpoint, I'm going to pick the start endpoint and the end endpoint. But then I get this function panel over here. So one of the things I can do after giving it the start and the end is just increase the length. So I'll start it here and here, and then I'll just increase it to 1 inch. I'll do the same thing over here, create that line. Let's make it 1 inch long. And I can even lock in this 1 inch long line length. So you notice here, I grab the 2 points to build my line, but it doesn't necessarily, I can make a longer line even though I'm choosing the 2 points. So I'll pick a point here, and I'll pick a point here. Ooh. And make sure we're in 3D mode. So this is a good lesson, because I picked a point here and I picked another point, but it gave me some weird angle. So what I'm going to do is unlock the 1 inch long line, and I'm going to click on the 2 button over here to edit the second endpoint location. And I can repick it like that. Oh, it doesn't like changing the length. Well, you know what? I'm going to leave it right here for now. And we'll go back and change some of these. So sometimes I just want to get the basic lines created, and then I can go back and manipulate them later as I need to. So I'll create one kind of on the midpoint of these curves. Okay, so that's good enough to make this guy. So once I've got the line oriented in 3D space, if I go to Home and choose Analyze Entity, you notice it gives me the line, shows me the directions, all that stuff, and now I can change the length without it trying to change the orientation. So I'll change that to 1. I'm going to grab that line there, change that to 1 inch. And so I'm just going through these lines. and because of where the start and the end point are, as I change the 3D length, it's always going away from the start point. So for example, I'm going to make this one 1 inch. What happens, for example, if we get a line like this and the endpoints are going the wrong way? So for example, if I try to make this, let me just copy that value. So if I try to make this 1 inch and it goes the opposite way, what do? Well, I would X out so that it didn't take my command choice. I would go back in there and choose Analyze Entity. And in the line dialog, one of the options we have is to swap the endpoints. So I would choose the reverse endpoints. There we go. So now my start point's at the bottom, and now when I make this 1 inch long, it's going to extend it. Now, this is an interesting situation because what we want here looks to be a planar cut. So if we look at it kind of from the outside, we can see that this is a straight cut right here. If I use that line, it's going to have my cutter go from basically horizontal to vertical back to horizontal. So I really don't want to use this one here. So I'm going to delete it. And this one here, it looks okay, but really I don't want the path to wiggle so much. In fact, if I'm looking at it, I don't know if I want it wiggling much at all. So what's the first thing I can do to this thing? Well, I really want a way that I can manipulate this line in 3D space. So I'm going to save the part file because it's always good to save after you've made, a bunch of changes. And I'm going to click on that line, and then I'm going to choose the option under Tools here, because you notice it pops up Wireframe Selection Tools. I'll choose Dynamic. And so now I get this little gnomon that I can place on the part. If I click there, you'll notice it automatically goes into geometry mode. Underneath the advanced options here, you notice it says gnomon mode set to geometry when placed. I'm going to turn that off so that it forces me to always change into the mode after I've put my gnomon the way I want it. So how do I want this to be aligned? Well, I'm going to take my y-axis here, and I'm going to click on the cone. And what the cone does is the cone sets the y-axis normal to something. So you notice here my y-axis is now normal to that line. So, which is good. I want it normal, but I also want it, so what I'm going to do is leave it aligned there. So I'll click on it. That sets the alignment. Now I want the origin. So I'm going to click on the little origin ball, and I'm going to drag it down to the end point there and click. So what I've done is I've aligned my coordinate system to this line. I'm now ready to manipulate this line. So I can choose geometry. I'm now in geometry mode, and if I go back to basic, you'll notice I'm in move. So now I can use these little handles to rotate my line. So I'll click on the handle, and you'll notice we're rotating. And in fact, I'm going to go back and choose copy. So I'm going to hit escape. I'm going to choose copy so that we can see where we started and where we end up. And you notice I've got graduations every 5 degrees. So it was at about 45 degrees. I'm going to go, we may want a little clearance off this corner here. So let's go 10 degrees. So this one's at, you know, roughly, this guy's at 45, this guy here is only at 10 because I moved it 35 degrees. I like that. So I'm going to hit apply. Now we can delete this guy here. And this guy, because because I'm rotating this guy up for a little bit of clearance, I probably want to rotate that guy too. So I'm going to go dynamic. I'm going to click to place it. I'm going to choose, move this around a little bit. I'm going to click there, and I'm going to choose that little yellow pane. So that little yellow window, I'm going to click it. And now I can click on that face, and it's going to align me to that face. So I want to grab the origin, so I'll grab the little origin ball, I'll put it down there, and now I'll put myself in geometry manipulation mode. And what I'm going to do is just angle this guy up 5 degrees, and I'll put it in move mode. So this one I moved up 10. You know what, I'm going to move this one up 10 as well. So I did 5 first, I'm going to do another 5 there, and I'll hit apply. Then I'll grab this line here. I'm going to click to place my gnomon. I'm going to grab my little yellow window, click on there, click on the origin, click on the back there, and now when I rotate, got to be in geometry mode, I'm going to move that guy 5 degrees. So I rotated these two up by 10 degrees because I wanted a little clearance off this corner here. I don't want to move this guy because I don't want my rotation to happen until I get over in this corner. And then this guy's up 5 degrees. That one's 10, this one's 10, this one's only 5. And based on the fact that this one's like 45, we may want to go a little more than that. So, let me go back into dynamic. And we'll go a few more degrees. Why am I going more? Because I know I've already got 10 degrees here. I know that I've got like 45 here. So I want to kind of choose something that's midway between this guy here and this guy here as I rotate going up this curve. So what we're doing here is we're planning out the rotation of our cutter based on the geometry that we've got on the part and how we know we want to drive the cutter through here. Because if we just try to follow every single contour here, we're going to crash, right? If I go with a line that's vertical right here, so if I connect this edge on the solid and that bottom edge on the solid, we're going to get a cut that's going to come out, you know, kind of that's no good. That's not how we like it. Let's create a toolpath because we've done a lot of geometry manipulation, but we haven't got into cutting yet. So toolpaths, curve 5-axis. Before we do that, I'm going to turn on my contour here. Okay, so there's the contour I want to cut. There's my tool axis control lines. So I'll do a curve 5-axis. Let's go grab a flat end mill. We'll grab a 1/4 inch flat end mill. Make it tool number 2. Set some speeds and feeds. And we always want to put in a comment to tell us, what we're doing in that NC code. For a holder, I don't know what kind of spindle you got. Let's grab a Cat 40 holder. We'll grab some kind of collet. That looks good. Call it some kind of ER20. So, depending on how your machine is set up, if it has tool center point control, that gives us dynamic tool length offset. If your machine doesn't have tool center point control and it's a 5-axis, then you need to calculate the full pivot length in 3D coordinates, whatever that 2D length is from the pivot point to the tip of your tool and to the gauge face on your spindle. And so we would need to make sure that our tool length is completely accurate here. So we would measure the actual stick out in the real world and adjust this so that the gauge length of our tool match the real gauge length of the tool in the real world. So we'll put in, whatever that's supposed to be. And this is, 0.250 diameter. And then I always like to note the stick out length. So 1.0241 stick out length, and then whatever the total gauge length is. So 6.899, we're going to call that 1, and I'll say GL for gauge length. So that's my assembly name, so I know that I've got a holder with a tool and everything's been set up correctly. Under the cut parameters, this is where we tell Mastercam what we're going to cut, what our chain is for the curve. So 3D curves, you notice we also have surface edge, all and single. So if you did have a flat pattern and you wanted to cut all the edges on it, you can do that as well. That works for some simple geometry. In this case, we're going to do 3D curves, and I'll go into select it. So I'm in my selection. I'm going to go ahead and turn off the control lines because I don't want them messing with my geometry selection. And one of the tools we've got in order to filter our selection, we've got this settings or options button here. So I'll click on options. And now what I'm going to do is choose chain by color. So for the color, I'm only going to select a blue chain right now. So this is one of the ways it makes it easy to choose just what you want. So I pre-colored my chains. Now I'm going to choose just that blue cut right there. Now, we could go around this whole thing, but we're going to do just this cut for now. So I'll say OK. Radial offset. Radial offset can go plus or minus any amount. So I can set the radial offset to 10 inches if I want. I can set it to -2 inches. It'll let me type in anything there. So I really want to set it to be the actual radial distance of my cutter. If I go measure my cutter and it's it's 246 and I don't have 5-axis cutter compensation, then I want to make that 123. I want to take off the change in radius for whatever my actual tool diameter is. So right now we've got a maximum step of 1 inch. I'm going to set my maximum step to like 5 inches, and we'll set a cut tolerance here of like 4/10, because I want it to be a fairly accurate path. First thing I'll do actually is we'll just show you it with 0.1. So I'll do a maximum step of 0.1. And then on my tool axis control, I'm going to choose tool axis control lines. And then I'll turn on the lines and turn off the rest of the geometry so that it makes it easy for me to select these control lines. And I always want them pointing away from the tip of my cutter towards my tool holder. And I'm going to leave the defaults for now, but we're going to come back and talk about some of these things. One of the choices that we have is how far away we allow a line to be from the curve to still be applied for tool axis control. Right now, we're going to say, it can be up to 1/4 inch away. So I'll put that in there. Collision control, vector depth is set to 0. We're going to come back and set all this stuff. So I'm going to leave all the defaults and just choose OK. And this creates a toolpath, which is all right, but it's going to have some issues. So let's look at this in backplot. So I'll choose backplot, and we'll start stepping through the toolpath. So it's going to come and just kind of plunge right in, feed down, and then start cutting. And I'm going to go ahead and turn on the vector display. So there's this option here. And you'll notice we're getting a line every 100 thousandths of an inch. Now this is where it's going to start looking kind of nice for us because of the way that we've created these vector lines. You'll notice it's just going to go around this corner here. And this, you'll notice we started with a maximum step of 100 thousandths. So every 100 thousandths, 100, 100, 100, 100, we're getting a line. But you'll notice there's a bunch of extra vector lines here. And the reason we're getting these extra vector lines is due to our tighter cut tolerance. So if I go back in here into the toolpath parameters, and I set our cut tolerance to 2 thousandths, and we regen, and I backplot and get up to that point, you'll notice I get a lot less vectors through here. Less vectors means less accuracy. So there's this, you'll notice it's much more line to line to line. This isn't necessarily a smooth curve because I've told it the path doesn't need to be that accurate. So that's what that cut tolerance does for me. So I'll go back down to 4/10. I liked that. The other thing I'm going to do is I'm going to bump up this maximum step. Let's bump that up to 5 inches. So that reduces the size of my toolpath. I'll go ahead and save that. And now let's just backplot through it. So I start out, I drop in. Now I get one move to get up to this corner. It makes it across the corner. I get one move to get over to here. Now, because my cut tolerance is nice and tight, I get more moves to make that curve. Those are good. I want a lot of vectors there for that curve. Then we start rotating the tip. So all the way through here, we're getting these extra vectors, which is good. We want more vectors where we have more rotation. So this looks pretty good here. This looks decent over here. But there's still some more stuff we can do to clean it up just a little bit. So first thing that we're going to do, I'm going to change this cut tolerance. Let's go 8/10. And I'm just going to make that 125 so we see it in backplot. under the tool axis control, one of the things we've got here is angle increment. And what this is going to do, it senses how much change there is between our vector lines. And whenever we exceed whatever this angle increment is, it's going to put in additional vectors. So if I turn this off, that angle increment, you'll notice we get a lot less vectors coming up through here. But that's not necessarily that desirable. We're actually going to get a fair amount of jerkiness through here. So what I'll do is I'll go in and I'll turn on that angle option. And I typically will use some of these values. 1 degree. So a lot of times I'll use 1 degree. 1/2 degree. That's also really common, especially with routing parts out. Sometimes I'll even go like 2/100ths of a degree, 0.02. I've done 0.05, and down as tight as 0.01. Sometimes you need a lot of vectors to get smooth motion. Let's do 0.1. So I'm going to do 1/10 of a degree and let you see the difference. Okay, so we were at 3 degrees initially. This is 1/10 of a degree. And you notice that's a lot of vectors. So the result is going to be real smooth motion on the machine, but the other effect is going to be thousands of lines of NC code, which is really too much. We need to find a happy medium. We want enough vectors that the motion is smooth without it being too much NC code. So that's 1 degree, and that actually looks a lot better. Now, the other thing that can be kind of hurting us I created this line here because we've got this cut that goes around that's pretty vertical. It's a pretty sharp cut there. But the question is, do we need to rotate that much to cut this edge? The answer is no, we don't. We don't need to rotate as much as this is in order to cut, to just cut this edge over here. If we stay at that angle, we can stay at that angle from here to here throughout the cut. And in fact, we could probably stay at this angle, which is even kind of less sharp than here. So let's see what that does for us. I'm going to do a dynamic translation. I'm going to set it to copy, multiple instances, and I'm going to choose the Z normal. So I'll choose the cone and put it normal to this line here. I'm going to choose the back end and choose that guy, and then I'll go down and choose geometry manip. So I'm going to choose that point, and I'll put one there, and I'll put one there. And I'm going to choose that line and delete them. It's going to give me a warning. I'm going to tell it I want to delete all selected entities. And in the curve 5 axis, I'm going to go back into the control lines and choose those lines. And what we should see is a lot less extra vectors being created. And we have a lot of rotation between here and here. We don't have as much rotation between here and here if you think about spanning these two vectors. So I'm going to take that one and delete it. Then I'm going to regen. Let's go back into the parameters. And for the angle, I'm going to set this back to 3 degrees. And under cut pattern, we're going to do 4/10. No, 8/10 is, let's try 1,000. See what that gives us. Maximum step, we'll say 2 inches. Every 2 inches, we want a vector kind of no matter what. So we've got our vector lines here. Under collision control, the vector depth is what sets our plus or minus amount above or below the chain. So let's go 1/8 of an inch below that chain. And we'll say okay. And the other thing that we're going to do to manipulate this, we're going to go back in the parameters here. All that stuff's good. Under linking, we're going to go to entry and exit. And for the entry, I'm going to tell it to use an entry curve. And we'll set the length at 0.5. We're also going to turn the feed rate down a little bit. So we'll use, say, 50% of the feed rate. And let's go more like 625. On the exit, we're going to do the same thing, but we're only going to go 1/4 inch past the end. Curve tolerance determines how many vectors get output here. So let's drop that down a little bit. And everything else looks good here. So you'll notice, depending on how the chain was constructed, this guy looks great. This little entry looks nice and straight. This exit, it's going out kind of tangent, but there's no drop down. So what we'll do is add just a little bit of negative height to that. So on our exit curve, we're going to go height. We're going to go, will only let us do. Now, because it's not feeding out tangent, what I'm going to do is I'm going to turn off the exit curve. I'm just going to use an entry curve. Notice it's left it, the path dirty. It needs to be regenerated. I'm going to go into levels. I'm going to go and turn on that part there, and I'm going to go into my wireframe, modify length, and we're going to extend this piece of wireframe a little bit. And by doing that, it'll still have kept this wireframe as part of the chain. So when I regen, now I can use my lead out to get up and past that. So we'll turn this on, still set to 1/4 inch. We're going to go at 100% feed rate. That looks better. So now what I get, because I've manipulated my path, I get the entry. So there's my entry move. I've got it set to every 2 inches, so I'm getting a vector here. I'm getting a vector here, 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 here. We go around the corner. Now, if I wanted this to round the corner a little bit, I would put a little fillet on my geometry to get it to round that corner. And now you notice that our tip is set below the edge that we're cutting because we did that negative vector depth. Now the cutter's coming up and it goes past that edge, and then it goes up for our lead out, and then we get our nice retract move here. Okay. So, Thomas, you had asked about some things like how do I do rough passes? So in the curve 5 axis, there's this roughing option, and you notice we get depth cuts, which is cutting down multiple steps kind of along the tool axis, and then we get multi-passes, which is a step over. And so in this case, let's say I want one rough pass, and then one finish pass with whatever finish amount you want on there, maybe 1 millimeter 40 thousandths. So I'm going to set this up for multi-pass. In linking, this chooses what our clearance and all that stuff is in between the passes. You have an option to use clearance only at the start and end of the operation. But if you do that, you have to make this retract move large enough that it can get from the end of one chain to the start of your other chain without crashing. So I'll turn off this because I want it to go full clearance. We tell it keep tool down within 300%. That should be good. So I regen, and now what we get is this multiple passes. So the first pass stays 40 thousandths away because I told it to, because that's what I said I wanted my finished pass to be. So it makes one pass, then it comes back in, and it makes another pass. And this is going to make a nice part for us, because what we have is lots of vectors in the areas where we need it, where we've got a lot of rotation, a lot of transition. And then in straight cuts, like from here to here, it's just a straight line. So it just goes up there, and then it starts rotating again, because we've got that 3-degree rotation. So if I go back into tool axis control and tell it, let's go every 1 degree. So everywhere there's a degree, it's going to output an extra vector. And you notice we're still getting the same kind of results through here. So let's see how tight we have to go before it starts affecting that, before we start getting extra vector output. So if we go 0.5 instead of 1, still not affecting it that much. Let's bring that back up. Now, one of the things in 2022, you can leave this dialog box open and you can continually regenerate the path, which is awesome. So if I set this to a 1/4 degree instead of a 1/2 degree, and I regen, that's better. Now you can see it's actually affecting it. So we're getting actual extra vector output here. We're getting a little extra vector output here, but some of that is also from our cut tolerance. So let's go back in here to cut parameters. Let's see here. Two-axis control. So what I'm going to do here is 0.4. Change that distance from curve there. That's better. So we're not super tight through here. We're getting a few more vectors output there. We're getting nice clean code for cutting that shape. And you notice my retract, I'm coming out far enough that I can get from the end of this cut here to the start of that cut there with no problems. So what happens when we need to make a cut on the other side? We could certainly create these vectors on the opposite side. We could also mirror those vectors and we could create another path. But we have another option. So the other option is under Toolpaths, and it's called Toolpath Transform. So transform the selected toolpaths to a different location or orientation on the same part file. So if I take this curve 5-axis path here and I do a toolpath transform, I'm going to choose mirror, and tool plane lets you do multiple copies with different work offsets. In this case, we want to do full coordinate. So we want the tooltip coordinates on the other side. And this is the one that we're going to mirror here. Source, I believe, is going to be NCI. Now, the other thing we can do here as part of this is just tell it to create new operations and geometry. One of the things I like about doing it this way is that it basically just mirrors everything. It gives you a new operation, and then you can go manipulate that operation if you need to make changes later on, which is pretty, it's kind of a cool option there. In this case, if we go into the mirror side of things, it wants to know, what are we mirroring about? In this case, we are mirroring about the y-axis, but we're mirroring about a point. So I'm going to click there, and it says select the reference point. I'm going to choose the midpoint of the model. You can also notice cutting direction, maintain start point, maintain start entity. This can affect so there's multiple choices depending on if you're doing a 2D operation like a regular contour, or if you're doing a 5-axis operation. So I'm going to turn off mirror plane because I want it to still choose the source operations tool plane. And we choose OK. And so what we've got here is a set of X, Y, Z tooltip positions and UVW positions, which drive this double cut right here on this edge. And through the transform mirror x-axis coordinate position, I've now got the reverse of that happening on the other side. The problem is here I'm Klein milling, and for for plastics and some composites, you actually want to be conventional milling. So I probably want to reverse that. So here I'm dropping in and I'm cutting up, and it likely doesn't matter because I'm slotting on both these cuts, but it may. So that's kind of the thing you need to determine, basically, is do you want it to be Klein milling, do you want it to be conventional milling or not? Now, if I posted this out, these tool positions, because I used coordinate, it would just change the tooltip positions of my tool with the same machine. So this is how we can program one cut and then do a translation, or in this case a mirror, to get the next cut on the other side. So I probably wouldn't do that with this cut on top. I'd probably make that all with one cut, and the same on the bottom here. I'd probably make that all with one cut. And in fact, we may choose to just go around this entire shape in one go, if possible, right? The other thing that we can now do, I've got these two cuts on one side of my part. I've got another part on the opposite side. So if I go in and do another toolpath transform, and I transform these two, and I say I want to mirror it coordinate, and I want to mirror the NCI, in my mirror, I'm going to choose the X coordinate as the origin point, And we're going to do the source operations tool planes again. Now I may have to do this in two paths. I may have to do this guy only. Right, so I've got this guy cutting over here. And that's all good. Then I'm going to do another transform toolpath for this guy. Yep. And all that looks good. Because what I have to worry about as I go from these cuts, you notice here I'm making this cut, but then I am moving basically from the end point vector here to the start point of this next cut. So in simulation and in the machine, you know, depending on how this operation occurs, this could be a crash right here. This could be like a crash waiting to happen. So in Mastercam, sometimes just the way that you plan the order of operations to occur can eliminate some of these potential crashes just by you carefully choosing the order that you want to cut your chains. The other thing that we can do is we can use another operation called a point operation in order to reposition our tool. So if we look at where this cut ends, you know, this is the first cut here, it makes its rough cut, it retracts, and then it ends right here. So our tooltip ends right here. I want to get my cutter over to the other side of the part before we change the orientation of the head. And so the way I'm going to do that is I make sure we're in the top plane here, so top WCS, construction, and tool plane. I'm going to look at this from the top view, and I'm going to select all these operations here. And then I'm going to choose a Z point. Let's do a Z of 20 inches. And I'm going to go into my wireframe geometry creation, and I'm going to create a couple of points. Create a point here. Create a point here. Let's create one here. And let's create one, say, here. And what I'll do is start analyzing these points. So I'm going to select that, go to the home, and then analyze entity. So it's roughly 10 inches. Let's go ahead and make it 10. And it's roughly 12 inches. Let's make it 12. And let's do the same thing over here. So we're going to make that 30. And we're going to make the X 12. So this is 12 and 12. This one here is 10, and this one's 30. So I'll click over on that one. We're going to go minus 12. Make it 30. We'll click on this one down here. And I'm going to make it minus 12 and 10. So I've got these new 4 points that are up above the geometry that I want to connect. So the first thing that I can do, I'm going to take this guy, I'm going to right click and hold down, I'm going to drag it up to transform number 3 and let go while continuing to hold the right mouse button. And when I do that, I'm going to get this little menu that pops up. Move before, move after, copy before, copy after, or cancel. I'm going to choose move before. And what I'm doing is I've got this cut here, then I'm jumping across, I'm doing this cut. Well, then I want to move over because that means that there's less repositioning to do. Rather than having to jump back across the part, I can go directly from this cut and I can move over to my next fixture to this cut, and then I only have to worry about getting in position for this cut over here. So we've got this one, we've got this one, We got that one and that one. So let's do this. Between this guy, well, I think we can plan this out a little better because I think this guy is the next one. So I'm going to move this one ahead here. So move before. We got this one on the right, this one on the left. Move before. So this one in back, and then this one. So we're going to go 1, 2, 3, 4. So the only place we have to worry about a transition is between these two cuts, because I can move safely from the end of here to the start of here without worrying. So what am I going to do? I'm going to go to operation number 2 here and move my little insertion point. And then I'm going to right click and I'll choose Mill Toolpaths and I'll choose a point operation. And a point operation is kind of one of the simplest Mastercam operations we can do. It's really just moving point to point. So I'll choose point, and it says select the point to move to. We're in rapid mode. So I'm going to choose this point here. Now it says select the point to move to, and I'm going to choose that point there. That's it. This is just a transition toolpath. It just gets me from one point from here to here. And I can do, I can change between rapid and feed rate. I can make a simple little cutting program if I really wanted to. But this is mostly for repositioning your tool. So I'll choose OK. And I'm going to make sure that we've got our same 1/4 inch diameter tool selected. Okay, I'll say reposition to other side of part. I don't really care about a feed rate because both of this entire move is made at rapid. And if I select all these operations, what you can see is that I'm planning the path of my cutter. So I've got one rough cut there, followed by a finish cut. We move over and we reposition down to this other cut here. So it moved from this vector down to that vector there. We make our rough and our finish cut here. We retract. Now it goes up here. Now it goes across. Now it repositions down to the start of the next cut. And it cuts over there twice. Those are 2 cuts. It's going to retract out. You notice it shows it moving correctly from here to here. And then we do our 2 cuts over here. So there's an example of using curve 5-axis. We also talked about transform coordinate NCI. We happen to use transform mirror. There's also transform rotate, which we could have done in a similar fashion if we had picked coordinate rotation and just created a rotary center point here. We could have rotated the cut from here to here, and around the part if it's symmetrical. So there are all kinds of cool options for transform toolpaths. We also created a point operation to reposition from here to here to get us to the other side of the part. We did a little bit of work with dynamic to both position the part and also to create some vector lines. So it's getting on towards 6 o'clock. So I did this demo here mostly for Tom. Let's see. So I'm going to send Tom a text just to see, if there's anything he can get thrown on here. I'm not really, let's see. let's see, we are back. No, nailed this part already. Oh, here we go. Keep code on one side, mirror the toolpath to the other side. You have to mirror two parts from the top. Good job. That's exactly the stuff I need to know. We rewatch and makes lots of notes. Yeah, man. I mean, thing is, there's so much to cover. Because like I said, you started with the 5-axis, which is kind of like the deep end of the pool to jump in and start swimming. And there's a lot of tools that exist in Mastercam to allow you to do all kinds of things. And sometimes it can be a geometry manipulation problem, like the geometry itself is bad, so you have to rebuild a surface. I mean, we haven't talked about surfaces yet. There's a whole ton. So setting the WCS really for you is really not going to change. I mean, normally the WCS is going to be the machine coordinate system. How is the part physically oriented and aligned on the machine? And you have the advantage of your tool moves around the part. So on a gantry router, the part, I mean, I know it moves in X, right? Like your particular setup, but what we have to think of with the gantry router is your tool moving around the part. So we set these parts relative to where this origin is, and we align these parts to the top WCS. So for a gantry router, you're really almost always going to use the top WCS. Now here's a little bit of something to be aware of, okay? When I start creating a part, even if it's just a single part on a gantry, in this case you got a mirror, I get it, you got an as and an opposite, you're cutting it out of the same blank. But I never will use the existing top, front, back, bottom, right, or left views. These are what they call the system views. And you notice down here the origin is locked into position. So these are the Mastercam system planes, and they can't really be edited. Which means if you end up having to tweak your geometry, you actually have to physically move the geometry, and that can screw up all kinds of things, including your depths and your tool paths and some other stuff. So what I end up doing is this. I right click on top. Never use create relative. So the create relative command has been kind of broken for, I would say, 3 or 4 versions. So in Mastercam, it used to just create a relative plane, like a new plane, and everything was good. It was plain, it was separate, everything was awesome. When you use create relative now, it actually creates a plane that is linked to the plane you originally used to create it. So if you end up having to move a plane or a plane origin, all of those newly created planes are dependent on that first plane. So it can really bite you in the butt if you're not aware of that dependency. So what I use, I don't use create, sorry, is it create relative? No, sorry, it is create relative. What I don't use is rotate incremental. So rotate incremental will really mess you up, and duplicate will also really mess you up. So creating a duplicate plane literally ties it back to the original. So, sorry, don't use duplicate and don't use rotate incremental. What you want to use is create relative. So that duplicate will screw you up. If you use create relative, this creates a new plane that has this relative orientation to the plane that you're creating it from, but it's not tied to that plane. So what I do in this case is something like this. I create a new relative top plane. And And I typically will say something like this. I'll typically just call it my top WCS. And because you're using a gantry, you really only ever need to set this one plane. And as long as your geometry is located relative to that plane, you should be good to go. So you notice I click on equals and it makes this top WCS. Part of the reason I do this, I make this new plane, and then I would make sure all of my operations use that plane. So I'd go in my curve 5 axis here. Planes, and then I choose top WCS. So you notice it makes all my transforms dirty because they all reference that. And then in my point op, I also want to select my top WCS. So I've got everything set to top WCS. Part of the reason I do that is in my planes dialog, I can set my work offset. So all these values, if I set it to 0, that's going to use my first work offset. I know they start counting at 0. 0 is 1. It makes no sense, but that's computer programming. Okay, so 0 is the first work offset, it's G54. So 0 is G54, 1 is G55, 2 is G56, 3 is G57, and so on. So I'm going to set that to 0 and set it to 0 there. And that way, anything that's created in this top plane should have a work offset of G54. Now, you're only going to get a G54 based on your post-processor settings. So I don't know what particular post you use, but we can talk about just a regular default mill post, like what's in the options with the default MP fan post processor, because this is kind of important to know. When you look at an operation, every operation is input to the post processor. So all of these dialog box parameter options are used to manipulate the post processor output. But there are some special options called misc values. So the misc values stands for miscellaneous values, and you get 10 integers and you get 10 decimal numbers or real numbers that you get to pass to the post processor. And these strings are read directly from whatever post processor you've got selected. So if we grab like a postability post, of course I don't have anything updated yet. Give me a sec here. MP postability, yeah, I do. That's fine. So I just wanted to show you something. We'll use the A100. So So give me a sec. I'm just gonna update something from 2020. This A100 Makino. Okay, 2021. So we open up the control def. Tell it to save as 2021. Machine. All right. So the other thing I'm going to do is I'm going to run the update post utility. So I press Alt C. So I'll do update post. Let's see. Make sure. Posts. Keynote 100. Override it, yes. Override it. Come on. Okay, so it tells me it got updated to 2021. So now I can open up a machine definition. Sure, 2021. Make sure we're opening up the right control definition. All right. Make sure it's set to 2021. Yes, it's set to 2021. Set to 2021. We're all good there. Save it, save the database. All right, and we say yes, and then new. Then we open up this guy. Okay, so just updated the post for 2021, this MP postability, and part of the reason I wanted to load a postability post is to show you we looked at the misc values page in Curve 5 Axis before, and all the strings, by the way, are common throughout all of the Toolpath dialogues. So you'll see that in there. So I'm going to turn this off now to automatically set to posting values. And what you'll see here is that the guys at Postability, sorry, I'm having a little bit of a moment. So for those of you guys that don't know, Dave Thompson, the chief developer and owner of Postability, just recently passed away. He died of a massive heart attack. So, you know, I know his company's going on without him. He's hired a lot of really smart people. I helped train a couple of the guys that work there, and did, you know, conducted a couple basic Mastercam post classes for them so that they could learn how the post processor works and, you know, get familiar with all that stuff. But yeah, unfortunately, he is not with us anymore. But the way that he set this up is you use these different miscellaneous integers and miscellaneous real numbers to turn on and off different things for output. So you notice right here, miscellaneous integer number 6, units per rev feed output. So this changes the output from like inches per minute or millimeters per minute to units per revolution. So for example, with tapping, instead of G94, you might want to be in G95 mode. So it's going to control that. For rotary, you notice it says rotary, 0 is post, 1 is lock, 2 is break, 3 is off. So you can control the rotary axis locking, you can control the tilt axis locking, tool breakage detection. So do we want to run tool breakage detection at the next tool change? Yes or no? Now these options are all going to be customized for your particular machine. So if you don't have tool breakage detection functionality on your machine, you're probably not going to have this control available in your post. So keep that in mind. Rotary start. This is used to pre-position your C-axis. So if you wanted to start by pre-winding the rotary up -180 or +180, so that you can, start out at C 180 degrees, and that way you don't trip your rotary axis limits. You can do that. It's got options for retract. If you want to retract, do you want to retract Z only? Do you want to do, which axis do you want to do? 1 is Z, 2 is Z, then X, 3 is no. So there's all these options that are created. You'll notice this was for a Makino. So there are machining modes that are set up here. 0 through 5 equals M250 through M255. So if you did a 0, you're going to get M250. If you did a 1, you're going to get M251. If you did a 2, you're going to get M252. And this is all input that controls functions for output in the post processor. So that's the design of these miscellaneous values up here. So we can certainly talk more about WCS and planes and all those other things, kind of in our next session. I'm guessing my wife, let's see, parts versus the world. For 5-axis posting, in general, we typically recommend that you take your parts and you move them back to the top view, what we call the world WCS in Mastercam. You could potentially create a WCS that's out in space that is just rotated to fit your part and post directly from that WCS. But you've got to make sure your post is set up to read a WCS that is not the system top. So with a postability post, you're probably okay. With a Mastercam post processor, I always recommend people bring the part back to the world WCS. Now, the only place where you'd really want to use a tool plane on a 5-axis trimming part like this is if you wanted to do something like tilted work plane. So G68.2 allows you to take advantage of canned cycles for drilling and tapping on a 5-axis head machine. So if your machine is set up for it and your post is set up for it, you could, for example, on one of these angled faces that is not, the face isn't planar to the G18, G19, or G17 planes in Mastercam, you could, for example, create a tool plane on the part, set up your post for tilted work plane output, and then you can tap perpendicular to a non-planar face by using the G68.2. But again, you've got to have a post that's set up to do that. So, I think you're doing good on the curved 5-axis part of it. We'll definitely talk about drill 5-axis. One thing I can show you just real quick on these holes, I would go in and do model prep and I would do hole axis. So with hole axis, we go and we select the internal holes on the part, and if it gives you the wrong direction, pretty sure you can click the arrow so that it goes the right direction. And now it wants to know, what kind of geometry do you want? Do you want points on top, on the bottom, on both? I'm going to say I want a point on the bottom. I don't want a circle. I've got my lines here. Extend the top. We're going to go 0.8. So I'm getting a point and a line. And that's exactly what I need for drilling for 5-axis. So you notice it says Control plus click to select all faces with matching diameters. So I'll hold down the control key and I'll click on that face, and you'll notice that I'm getting new vector lines on all of these holes. So I held down control, I clicked on one of the faces, and now I've quickly created points and lines for these drilled holes. So I'm going to go ahead and turn my levels off, or sorry, my solid visibility off. I'm going to go into Toolpaths, and we'll give all those a regen. Drop that. So when I get ready to drill this, see how big it is. Go and analyze that. All right, so it's 135. You know, I could circle mill that with 125, but if I had a 130 drill, I could just drill it. So in Toolpaths, I can always go to the Toolpath menu here. We've now got rid of the multi-axis drill. So when you're looking for drilling in Mastercam, it's just drill, and you can choose the multi-axis part of it through drilling that way. If I right click and I go to Mill Toolpaths, yeah, so they've gotten basically, they've gotten rid of the 5-axis drill. So you just choose drill. And what do we want here? So I'm going to go and choose these 4 points. And for my tool, let's just create a new tool. We're going to give it whatever size it needs to be, 130, 128, whatever that actual drill diameter is. Yeah, everything looks good there. So I give it some basic parameters. We say drill 4 holes. Give it a holder. So 130 drill, and it is 1.5 stick out length, and it is a 4.420 gauge length. So give it that info. Under the cut parameters, we're just doing a regular drill. Under tool axis control, we're going to go 5-axis. Tool axis control, we're going to go parallel to line. So it says select lines. And I may just be able to choose one line because all 4 of these are angled the same, but I'm just going to grab all 4, right? So tool axis control, parallel to line, clearance, we're going to go 4 inches, incremental, retract, we're going to go like 1 point, let's go 1 inch, top of stock. Now this may be incremental from the depth. So there is some options for calculate incremental values from the holes lines. I miss the old 5-axis drill, to be honest. So we're just going to go minus 0.1, and let's see what this gives us. that's what I thought. So it gives us the full retract. Use only at the beginning. So let's turn that on. There we go. So now we're doing the 5-axis drill. We've got our approach point there. We drill in, and I can make these lines shorter because right now you notice it's using that 1-inch retract. If we give it, say, 0.25 retract, let's see what that gives us. There we go. So that keeps us closer to that face. So now we start 4 inches away, plunge down, we drill our first hole, go translucent on that so you can see it sticking through. So we drilled through by 100 thou, past the point, and we drill all 4. And then we retract out. Right, and then we can switch to our end mill and we can mill those slots. You know, if we had a 1/8 tool, right, we could probably do this whole thing with a 1/8 tool. We could mill those slots with a 1/8 tool. We could plunge those drill points with a 1/8 if we had a center cutting tool that would work for our particular material. So we could potentially cut this whole thing, you know, without having to do a tool change. But there could be an advantage to doing a tool change, right? We use a small tool for the small features and a bigger tool to cut the bigger features. It can go faster. So maybe, you know, a 1/8 drill for drilling these, you know, a 1/4 inch end mill or a 3/16 end mill for milling these slots, and then a 3/8 or maybe even a 1/2 inch end mill for cutting the periphery. Depends on what you got, depends on what your kind of standard processes are. A lot of what if questions, you know, but you know, hopefully this was useful. I think we talked about a lot of different stuff. I know there's always so much more to cover, but you know, I think this will give you some information to chew on, and you know, some video stuff to review and go back and you know, come up with some more questions. We'll do this again. So cool. All right, guys. Like I said, I know we covered a lot of stuff. There's always more stuff to cover, so you know, hopefully that was useful to you guys, and you guys got something out of it. And I think I'm gonna go ahead and wrap this up. So thanks for joining me, guys. See a lot of people were chiming in here on the live chat. All right. All right, guys. So yeah, hope you guys enjoyed it, and I'm gonna go ahead and kill the stream. So thanks for joining me, guys, and see you guys later.